Hello, this is Mr. Stansbury. I'm going to take you through some of the problems on the 8H assignment. Okay, first one we're going to take a look at is number 1. Without using a calculator, find natural log of e squared. So if you remember, natural log is the same thing as log base e to the e squared. So really what this is asking is e to what power equals e squared. So look, since the bases are the same, x is going to have to equal 2. Okay, same thing here. Log of e equals log base e of 1. So they're saying e to what power equals 1. In this case here, you just got to remember that anything to the 0 power equals 1. So x has to equal 0 in this case. Okay? All right. Number 3, use your calculator to evaluate e and e squared correct to 3 decimal places. Okay, so let's do that. All right, so we've got e to the first, because we can't just, won't let you just put in e. So 2 point to 3 decimal places, 2.718. So e equals 2.718. E squared is then going to be, e squared gives us 7.389. Okay, and it says explain why natural log of 5 lies between 1 and 2, because that 5 here fits in between 2.718 and 7.389, right? Because remember, ln of 5 is the same thing of log base e of 5, so we're saying e to what power equals 5. We know e to the first is 2.718. E to the second is 7.389. So that natural log of 5 has to be in between here. That's pretty straightforward, hopefully. Okay. Use your calculator to find natural log of 24. Okay, so ln 24 gives us 3.1781. That's a 3. Okay, 3.1781. Oops, I messed that up. 3.1781. Okay, hence write 24 in the form e to the k. So that means, because it's ln of 24, which means log base e to the 24. So we said e to what power equals 24. We just figured out that it's that right there. Okay, so we would write that as e, oops, my computer's glitching a little bit here, e to the 3.1781 equals 24. Okay, so that's our answer for that one there. Okay, all right, let's take a look at, there we go. Use your calculator to write the following in the form e to the k, where k is correct to 4 decimal places. Okay, and we get, we're trying to figure out that 6,000 here. Okay, so 6,000, they're basically saying equals e to what power, right? So we're going to find the natural log of 6,000, right? And that gives us 8.4 decimal places. It says 8.6995. 8.6995. Okay. So that means that's going to be this power right here. So we do 6,000 equals e to the 8.6995. Okay, and just to show you how this works, we'll do second e to the, and we'll do 8.699995. Push equals, and look, there's our 6,000. Okay? Okay. Number 10, Hicks' law models the time taken for a person to make a selection from a number of possible options. For a particular person, Hicks' law determines that the time taken to choose between n equally probable choices is t equals 2 natural log n plus 1 seconds. How long will it take this person to choose between 5 possible choices? Okay, n is the equally possible choices. Okay, so we're just going to plug in 5 for this n right here. So t is going to equal 2 natural log of 5 plus 1. So t equals 2 natural log 6. So really we can just plug this straight into our calculator. 2 natural log 6. And we get 3.58 seconds. Time equals 3.58 seconds. Okay. And then for 15, we're simply just going to plug in 15 instead of 5. So we get t equals 2 natural log 15 plus 1. So we'll do t equals 2 natural log of 16. So let's see what that does for us. We got 2 natural log 16, and that gives us 5.55 seconds. Okay, and those are those two. That's a little weird because it seems like it would take, like if you've got 5 choices, that seems like, depending on what you're choosing on. But if you've got 10 more possible choices, it's only going to take you an extra 2 seconds to choose. That's interesting. Cool. Anyway, that's all we have for the 8H assignment. If you have any further questions, please feel free to ask. Thanks.